And I once again welcome all the delegates and the participants of this Indian Aluminium Summit. It's as you know, aluminum is a very important metal for not only the industry but also for the economy of the nation, and that is why a lot of emphasis has been is being given to the aluminum as a metal and processing of aluminum and developing different applications of aluminum for various sectors. So we are all here to discuss the present status and the future prospects of aluminum industry in this country. And we have dignitaries with us at the inauguration session. We have with us Professor Amol Gokhale. I welcome Mr. Amol Gokhale. He is president of IIM. And Mr. Gokhale did his BTech from the Indian Institute of Technology, Bombay, PhD from the University of Pittsburgh, USA, and worked for the Defense Metallurgical Research Laboratory in Hyderabad. Retiring as a director in 2015, he has then joined IIT Bombay as full-time professor. Professor Gokhale's research contributions are in light metals, including aluminum alloys, magnesium alloys, metal foams, and niobium alloys. Currently, he is pursuing research in shock mitigating designs and materials, niobium alloys, and high-strength steels. He has published over 80 journal papers, 40 technical reports, and edited a book on aluminum lithium alloys. He is a fellow of Indian National Academy of Engineering and president of Indian Institute of Metals. Thank you very much, Mr. Amol Gokhale, for joining this inauguration session. And this may be to tell everybody that this may be Professor Amol Gokhale's last public appearance as president of IIM, because his tenure is getting over on 31st of this month, isn't it, Dr. Gokhale? So
yes, and
thank you and congratulations for a very successful tenure, and thank you very much for joining this program. We have with us Mr. T.K.Chand, and Mr. T.K.Chand, as you know, is now resident director of Vedanta. Before that, he had a very long career with NALCO and as CMD of NALCO. And before that, if I don't know how many of you know, but he was in Vizag Steel Plant. He was CMD of Vizag Steel Plant. And I have pleasure of interacting with him since he was CMD of Vizag Steel Plant. And thank you very much for joining Mr. T.K.Chand for this inauguration session. And on such a short notice, you could join. That was a very nice of you, sir. Thank you very much. And then we have Mr. Ashok Nandi. Ashok Nandi is president of IBAS, International Bauxite, Alumina, and Aluminium Research Society. So, Mr. Nandi, just a minute. I will introduce Mr. Nandi also. He is actively involved in evaluation of various bauxite alumina projects in the world. He is one of the founder members of IBAS. During 2007-2012 period, Dr. Nandi worked as senior geological consultant to BHP Billiton in Australia. Also worked as geometallurgist in alumina refineries in India and Australia. Presently, he is consultant to bauxite projects in Geneva and Syria. Sierra Leone, namely Sierra Minerals Holding Limited, and Medco Access Minerals, Agbaza, Kenyan Resources, and Rio Tinto Alcan. Dr. Nandi has about 40 years experience in working in bauxite alumina industry, research and development and geological mining fields. Published more than 50 papers in the field of bauxite alumina. He is GORC competent person and also registered specialist of ASI Aluminium Stewardship Initiative. Thank you very much, Dr. Nandi, in joining us.
Thanks.
We are very veteran dignitaries with us for the inauguration session. And I would first like to call upon Mr. T.K.Chand for his inaugural address. Mr. T.K.Chand, please share your views on the present status of aluminum industry in the country. You have been associated with it for a
Good
long.
morning to good morning to all of you, and Professor Gokhale from Indian Institute of Metals, Mr. Nandi, Mr. Chandekar, other dignitaries, diaspora of metal world's readers, entrepreneurs, industry captains, and ladies and gentlemen who have all participated in this webinar. First of all, I give a huge thanks to Mr. Chandekar to organize this Aluminium Summit, Indian Aluminium Summit, in a time in the backdrop of second wave of pandemic, but a bullish market condition. Aluminium is a strategic metal. Many countries across the world, they have recognized aluminium sector as a strategic sector. It is also fast emerging as a future metal because it will come with aluminium. Future time is defined by 3 S. One is sustainability, another is saving, another is the speed. Anything you see in the future, it will be either speed. Look at the younger generation, the speed that they talk, the speed with which they operate the computer. Look at any vehicle, when you talk that what is its speed. Look at anything, when you talk of, they will talk of that what is its sustainability. So these three things, in my opinion, that define the future time. And incidentally, aluminum gives all these. Aluminum is a metal which gives sustainability, because we all know in aluminum family that if a dense metal is replaced, 1 kg of dense metal is replaced by 1 kg of aluminum, then 23 kg of carbon dioxide emission is seized over the lifespan of a vehicle. Similarly, you come to the speed. If aluminum is used, the speed is enhanced almost more than 50%. Similarly, in case of sustainability and saving also, it gives a quantum help. So when such is the potential of the metal, question arises that what is its growth? If we see the last 60 years, you'll see it is the aluminum metal which has a phenomenal growth. Because the growth of aluminum is almost, if you calculate in numbers, it is 20x, then others will be 5x to 7x. That's the type of, I was seeing the growth chart, that type of speed it has gained. And in my opinion, it will be gaining more and more speed. And if you see, if you take the number, that is CAGR of global growth of aluminum industry, when it comes to 5%, and in case of India, it is 10%. So the growth is taking place very speedily. There the question comes in such summit, that what are the likely issues and challenges that will be faced by the aluminum sector, so that the learned industry captains, players, those who are here, scholars, entrepreneurs, they will be debating that thing to find out solution to that, because that will be the takeaway of this such type of summit. When we talk of an industry, we don't talk of only the metal. We talk of the entire value chain, starting from bauxite till the market. In case of aluminum, it is the bauxite. From bauxite, it gets refined and then becomes alumina. From alumina, then gets smelted. Then it becomes aluminum. Aluminum becomes value-added products, and again recycling through scrap, etc. So like that, the entire chain is there. Then let me pick up first point first. That what is the problem with the bauxite? You see, right now, India produces around 24 million ton of the bauxite, because if we take the 4 million ton of the production. But way forward, this number will almost get tripled. So there is a need that the huge deposit of rich bauxite that are there, that need to come to the market. Government has introduced a very nice system of auction, a very transparent system. So bauxite blocks, one after another, it should come. Now the Kalrapat bauxite block in Orissa has come for the auction, and other bauxite blocks also. We are expecting they will come one by one. And what is required here is very crucial, is the exploration and making the blocks ready for the auction. That is one of the major issue. Along with that, a reasonable price, that average sales price need to be there, which will invite many players to compete. Then moving to the alumina stage, second stage, I am only picking up one issue because there will be several issues, but some stellar issues I am just picking up. Major issue will be the management of the red mud. In fact, when I was there in Nalco, we were trying with Chaliaco to develop some kind of arrangement so that from red mud we can extract the iron and it can again be processed, because you know that 33% of this iron oxide is there, but somehow that has not yet materialized, because most of our bauxite, particularly Panchpatmali area, they are cannot be, magnetic separation is not becoming suitable to it. They are trying to develop certain methods so that it can be economical, because it is not a question of extraction. It should be extraction which will be economical. So that is a major issue which is confronting there as far as the alumina is concerned. And then coming to the next one, when we talk of the major raw material, we should talk of the critical raw material. In critical raw material category, coal, caustic soda, city pitch, CP coke, etc. comes. Recently, while other raw material positions are now by and large are becoming comfortable, I was seeing the forecast. It is city pitch and petrocoke. These two raw material will be a matter of concern for the aluminum industry, for which industry need to make its strategy to make its availability sufficiently so that industry can deal with it. Then moving from there to the smelting, here the main issue in case of the stage of the smelting comes the emission of the gases and its management. Fluoride contamination is an issue which has to be dealt by the aluminum industry. Then coming to the product stage, in product stage, crucial issue comes that India and aluminum industry is in the fourth cost quartile, that high cost quartile. So our products should also move to high realization quartile to handle situations where the LME is very low. Right now, LME is very high, $2,400 per ton, but it will not be so for a long time, because I expect that by December or January, there may be moderation of the prices, because this price of aluminum is not supported by market fundamentals. Rather, it is because of certain policy issues by either by the China or by the Russia that prices are surging up. So when the prices of aluminum comes down, because when I joined Nalco, during that time, aluminum price was running 1587 average LME. Look at the average LME, 1580 is now 2400. So what a major gap. But I always tell that high price of aluminum is not good for the aluminum industry, because industry will not grow. Many smelters, etc., small things will come, and the market again will become glut, and there will be a fall of the prices, and then industry will suffer. Because a moderate price, making aluminum metal in various shapes at an affordable price to the people, that will make the industry to grow, because affordability can give you scalability. That is the main principle in the market. One has to keep it in mind. And then coming from the product to the scrap and its recycling takes on. Now, given these issues and the challenges, now I'm coming that let us see that we are in the aluminum industry. In the next 10 years, what happens by 2030, let us say, people tell that 2030. In 2030, the vision, aluminum vision, I can see that suppose we are right now having a consumption potential of 4 million ton and a capacity of 4.1. And I have seen, when I have done some of the homework in Nalco, there I have found that there is a correspondence between GDP growth and consumption of the aluminum. If you take the pre-COVID GDP growth, 1% of growth in the GDP corresponds to 0.9% growth in the aluminum consumption. By taking that, I tried to build up a model in which what could be the consumption of the aluminum by 2030. I found a figure that around 10 to 12 million ton will be the figure of aluminum consumption, and production capacity should be to that extent. So look, if we have to increase the production capacity to up to 12 million ton, how the aluminum industry looks like. That means 12 million ton, 8 million ton capacity more is to be added, which will call for 4 lakh crore investment. So look at the number, 12 million ton capacity in 2030, 4 lakh crore investment, and employment. Employment will be around 2.4 million. If you deduct the existing level of employment of 8 lakh, then additional 1.6 million ton, so 6 million employment potential is there in the aluminum industry. That's what the government need to look at the aluminum. It's a big employer it will become. And come to the MSME. Right now, we are at the stage of 4,000 MSME are attached to various aluminum industry units. Now it will grow to 10,000. Take a point that if each MSME gives 5 to 7 employment, then 70,000, 80,000 employment itself gets created. So this is how a picture is getting built up as far as aluminum vision 2030. Unfortunately, till now, aluminum industry doesn't have a national aluminum policy, as in case of steel, they are having a national steel policy. In fact, when I was in alcohol, so I have been advocating that, but somehow or other that could not get through. But I will continue to advocate whether it gets done or not in all forum, whatever I get it. In fact, yesterday itself, I was also talking to very senior officials of Ministry of Mines. I was advocating the same thing, that there should be aluminum, national plan of aluminum actually, so that aluminum industry grows in a structured way. Now let us come that whenever we talk of any industry, we talk of the Millennium Sustainability Development Goal, SDG, which we talk of, because without SDG, any industry will become very empty and blank. So some of the aspects of the SDG are there. One is that zero net mining, that concept which is getting talked, that in case of mines, because aluminum industry starts with bauxite mining, and zero net mining is the goal of the aluminum industry. Second is zero discharge, that is yet another thing, and zero wastage. These three are the sustainability goal that has to be that is there in the vision itself. And coming to the aluminum industry, that how aluminum industry will become sustainable, one of the major things I will advise all my colleagues in the aluminum industry, that is the cost of production reduction and making the prices of the aluminum affordable to the people. That will keep the industry floating around. India has abundant and rich bauxite resources. Fortunately, if you see the topo map, that bauxite deposits and coal deposits coincide with each other. And most of them are in Orissa, that eastern belt, most of them are there, and there the coal mine is nearby. So if we can leverage this thing, Indian aluminum industry will become highly competitive, no doubt in it. And to touch upon that, since I'm from Vedanta, I will just touch upon the Vedant's vision, what they are thinking of. Yesterday, I was having a discussion with their senior leadership, that Vedanta wants to move to the 3 million ton aluminum production and to be the first top 3 producing country in the world with the lowest cost of production. And you will be surprised that target is getting put to $1,200 per ton. That means from the right now, from the position around $200, $300 down below. Yes, technology has come. More particularly, it will be the technology for reduction of consumption of DC energy in smelter that will take make this target achieve. And with that, the target for bauxite, captive bauxite raising is 8 million ton and the coal 33 million ton. They have recently got 3 coal mines in Orissa. So I hope that target will get achieved. That bauxite things is to be seen. So all the players in the aluminum industry, they are major players along with the secondary and other players are now gearing up. The gearing up for the 2030, the vision in that direction, all are proceeding. And at the end, I will tell that let us all work for circular economy. And in that, Indian aluminum industry would play the pivotal role, making the country the Atmanirbhar Bharat. Thanks to all of you.
Thank you, Mr. Chan, for the really very enlightening and very interesting speech you gave, and it really will set the tone of the rest of the conference. I'm sure about it. Now we move on to our next dignitary. I would request Ms. Dr. Ashok Nandi to speak few words on this occasion. As we address. Dr. Ashok Nandi, please.
Yeah, good morning, ladies and gentlemen. I'm not so much experienced like Dr. Chand. He can speak complete value chain, starting from bauxite up to the aluminium downstream. I am highly confined to actually bauxite alumina field. I have worked almost like 40 years in this field, and that's what my area of specialization. So I will mostly talk in this area only because I have not much knowledge. Of course, while organizing conferences, we get a lot of papers on aluminium and downstream, but I will in general talk about the bauxite alumina industry. As Dr. Chand has correctly told, this is the time India should increase from 23 million ton per annum to at least to 30 to 40 million ton bauxite production. Unfortunately, many of these deposits in the Eastern Ghats belt in the Odisha and Andhra Pradesh have already been explored in detail. I'm still thinking why these deposits are not being auctioned, because there's enough work has been done. So this is one good sign is there that already Karlapat is on the line, and this Karlapat bauxite deposit will be shortly by September or October will be given to any mining company, most likely. Let us see how it proceeds and how it goes on. Just from my observation, there is a lot of work is required to be done in increasing production and productivity in alumina plant. And also, as Dr. Chand has told, that the bauxite residue is a big question. Just for your information, one of the biggest alumina plant in Australia, that is Worsley Alumina Refinery, where I had opportunity to do work for 6 years. They are using bauxite with 28 to 29% available alumina. This is why they are able to produce with such a low quality available alumina, because economy of scale. Unfortunately, India, we don't have such a big plant so far. And they get bauxite, they keep reducing the quality of bauxite and increase the resources. This is the attitude we have to follow in India also, because there are limited resources in India, and whatever new mines comes up, they should decrease the cutoff grade and use as much as material as possible. For example, nowadays it is very much possible to use the overburden laterites by simple crushing screening and not to waste any material which is being generated in the mines. For example, this is sad affair that a company like Nalco, of course, Dr. Chand is there, using up to 3.2, 3.3 tons of bauxite per ton of alumina. I understand there is an obsolete technology, old technology and other things, but this consumption pattern should come down below 3 tons. And I think with the new introduction of the new line where they are going for low temperature alumina refinery, this consumption pattern will go down. Another thing, which most of the alumina refinery in the world are now disposing red mud by dry stacking system. But it's still one of the public sector, Nalco is still continuing the slurry transportation and slurry disposal. These aspects should be properly addressed because it's the responsibility of not only private sector, but also public sector should go on this line to this. Now, for example, Vedanta and other Hindalco has almost using, that's what they claim, 100% of their bauxite residue in cement industry. They are having a proper dried red mud because that is a prerequisite for use in the cement industry. So, and the same line, I think Vedanta is also selling some of the red mud to the cement industry. But there is a lot of more work has to be done, and the target should be a zero disposal. There are many options are available, and at present, I think 3 and 4 R&D centers are working together to find the suitable use of the bauxite residue. So this is the area, and I will just touch a small thing that a country like Guinea, which was just producing 20-30 million tons 5 years back or 6 years back, is suddenly now producing 60 to 70 million tons per annum. And this is what happened because they had developed infrastructure, particularly Chinese. And Chinese have dominated complete mining scenario of country like Guinea. And their 70% bauxite supply is coming from Guinea only. You will not believe this is the reason the bauxite prices have never gone up. Presently, the bauxite prices are in Guinea. The one of the best quality bauxite is also selling at $25, $26 in this price. So you can imagine that bauxite has no relation with the LME prices. And in our country, still they have zoomed up the price of bauxite, linking it to the LME. There is absolutely no relation of bauxite with LME prices. This is simply availability of the material. If there is more bauxite in the market, it is cheaper. However, the freight is very high at present. But these are the things where India can also secure some long-term sources in country like Guinea. But since now Eastern Ghats bauxite are being developed and more deposits are coming in line, I think now Indian Alumina refinery has time to think about sourcing raw material from outside India. So these are some of my thoughts, and I'm going to present some papers, so I'm not going to repeat anything what I'm going to present in the afternoon. So I will just thanks to all of you for giving me this opportunity to talk in this inaugural session. And at last, I will invite Dr. Chand, Professor Gokhale to come and speak in IBAS 2022, which will be held during February 2nd, 3rd, and 4th in Raipur city. So we will send you individual invitation to Professor Gokhale and Dr. Chand, and will request you to make a keynote address and presentation in this conference. And we are trying to bring ASI, Aluminium Stewardship Initiative, because this has become a latest things, because ASI certification has become quite important nowadays, and they check everything for sustainability. And another which is coming along, a lot of talks are going on, is digitization of this thing and green metal. So how India can achieve these developments with whatever happening in the world. With this, I would like to thank everybody. Thank you very much. And Mr. Chandrekar, you can carry on further.
Thank you. Thank you. Thank you, Dr. Nandi. It was a very good speech about alumina and bauxite and their role in the production and their role in the future development of aluminum industry. Now we move on to Professor Gokhale, and I request Professor Gokhale to give his inauguration speech. How institute like Indian Institute of Metals looks at the aluminum industry, and also from the research and technology development point of view, how Professor Gokhale sees the future of aluminum industry. We are all very keen to hear you out, Mr. Gokhale. Please.
Thank you. Thank you, Mr. Chandekar. It was a great pleasure for me to listen to Dr. T.K.Chand, who spoke about the complete value chain. And I think really that's really the key point. And I'm myself very passionate about looking at the complete value chain especially for critical materials. I had done some work for the government earlier. And unless you have a complete value chain in your view, I think the vision becomes kind of incomplete. So it was a very good talk that he gave. I'm completely ignorant about the bauxite and coming up to the primary metal part of the value chain. And that's why Dr. Nandi's inaugural speech was also illuminating for me, because especially all these numbers that he spoke about, the consumption of bauxite to produce aluminium and all, I was not up with those numbers, and it was very nice for me to hear those aspects. Now, today I am speaking partly on behalf of the Indian Institute of Metals, and later I'll say something from the technology and the research point of view as well, which is based on my own experience in my own professional career. So in the beginning, let me just say something about collectively about aluminium, copper, zinc, and lead, which are four important commercial metals, and then I will restrict myself to aluminium. That, as you know, Department of Commerce and Industries is giving a massive push to infrastructure through the National Infrastructure Pipeline, whose investments by 2025 are likely to touch 1.4 trillion US dollars. And this is likely to give thrust to the fields of aluminium, copper, zinc, and lead over the medium to long term. Also, the government has identified 27 champion sectors, which include aerospace and defense, electronics, automotives, railways, construction, which have extensive applications for non-ferrous metals, which will provide a boost to the industry and the economy as a whole. So that is the starting point of our premise that growth is coming. I'll now provide a snapshot view of the commercial non-ferrous metals and especially aluminium now. So as we know, aluminium is, India is the third largest producer of aluminium, 3.7 metric tons per year. And also we are a large consumer of aluminium. So this is one of the fastest growing among the non-ferrous metals is aluminium. 3/4 of the aluminium consumption is accounted for electrical, transport, and construction segment. Once we know that, we know where to put our money. And there are abundant reserves of coal and bauxite also, as was just said. That is the strength of our country. So there is a driving force. We have the resources. We have the bauxite, as I said, we have coal. Also, we have ores for lead and zinc, the other non-ferrous metals. Only in copper, the industry mostly imports copper concentrates for production of metal. And there is sufficient primary capacity to meet the demand also, except that in case of lead, where the recycled metal is heavily used in the lead industry. There is a huge growth potential for these metals in general, as the current Indian per capita consumption is about 5 times lower than the world average. Similarly, the recycling capacity in India for aluminium, copper, and zinc is also below the world average. So when there are driving forces, when there are reasons to grow, there is infrastructure, there are resources, and also our per capita recycling as well as per capita usage is below the world average. These are all the conditions which, in my view, are conducive to a large expansion in the aluminium sector. The driving force for aluminium is obviously lightweighting. Coming to the technology side now. Lightweighting is achieved, however, by a variety of means. So if we think that aluminium replacing steel is the only reason for lightweighting, that's not quite correct. The other methods of lightweighting are also there, such as improvements in the properties of the existing materials. Thus, we see in the last several years developments in advanced high-strength steel, advances in composites, have also actually sort of reduced the pace of aluminium coming into the automotive sector. One can do the lightweighting by redesigning components, redesigning the vehicles. There can be newer fabrication methods, like for metallic materials, there has been friction stir welding, laser welding. They have eliminated the requirement of overlaps and rivets in many cases. That has also led to certain amount of weight saving. Sometimes switching to a newer material can put restrictions on the thickness of the metal that can be used. If a steel can be used, let's say in 1 mm thickness, if an aluminum of 1 mm thickness replaces that steel, that's great. But often that aluminum that we use to get a certain property combination may be of a thicker grade, and there reduces the weight saving potential of aluminum. So it's important not just to have higher properties for the replacement material, but also be able to produce the material in the same gauges that the conventional material was being produced. Reducing property scatter is an important aspect of lightweighting, because higher the property scatter, more are the safety factors used by the vehicle designers. And again, that affects adversely the weight saving potential of a new material. And compared to steel, as of now, aluminum castings are having more property scatter. And so there is all the more reason to invest in technology and make the properties more consistent. But nonetheless, it has been shown, and it has not been shown for the automotive sector, but it has been shown in the aerospace sector in the 1970s by Lockheed Corporation, that among all the different ways of lightweighting, material replacement by a heavier metallic material by a lighter metallic material is the most effective way eventually for lightweighting. So the interest in aluminum is very much there. For aluminum, what is further restricting the higher material cost? Automotive sector, we know, is very, very price sensitive. The property advantages on a unit weight basis today are not attractive. They need to be significantly superior to those of steel to be able to use aluminum. And the scatter in the properties I have mentioned also remains large. The fabrication costs are higher. Welding of aluminum is more tricky than steel. And also what matters to commercial products is they would like to have regular supply lines. And presently, the supply lines for aluminum more restricted compared to steel. And lastly, the incompatibility with other materials is another issue, because aluminum is an active metal. And when you join aluminum with steel, then aluminum becomes prone to corrosion. So it has to find ways to seal the joints so that you can use aluminum in conjunction with steel, because steel may not be completely replaceable by aluminum. Now, recently, the Honorable Minister for Steel, who has now become Minister for Education, Mr. Dharmendra Pradhan, he actually invited the Indian Institute of Metals for a brainstorming session for half a day. And the purpose of that brainstorming was to see how the Eastern Indian states can be turned into a manufacturing hub. At the base of the argument was the fact that a state like Orissa, which can be said to represent the 4 eastern states of between Orissa, Chhattisgarh, Jharkhand, and West Bengal, and maybe some parts of eastern Maharashtra and parts of northern Andhra Pradesh. But for Orissa, the GSDP, the GDP of the state on account of manufactured products, taken as a ratio with respect to GSDP for mining, today stands at about 18 to 19, at the most 20. So it is 20 times value addition done in the state of Orissa because of manufactured products. The same ratio for the state of Maharashtra today is about 225. So the GSDP on account of manufacturing is 225 times that of the GSDP due to mining. So between 18 to 19 on one side and 225 on the other, we can see that there is a tremendous growth potential if you establish manufacturing industries which produce end products in these 4 states, because they are they contribute maximum to raw material production. So the logistics costs will come down substantially if the manufacturing industries are also established in these eastern states. And after much deliberation with experts, including a couple of innovation cluster, manufacturing cluster developers from abroad also, we proposed to the Ministry of Steel, and we also communicated our findings to Niti Aayog, because Ministry of Steel may simply take a narrow view and only look at the steel part of our recommendations, but our recommendations are for other metals also. So coming to aluminium and the result of our brainstorming, we propose to the ministry to establish few manufacturing clusters in and around the eastern states. The first cluster we recommended should be aluminium for automobiles. This is fueled by the higher environmental compliance standard, which is BS6, which will need lightweighting and hence more aluminium. The applications are variously in engine castings, which have been there for quite some time, the powertrain parts, the cylinder blocks and heads, alloy wheels, steering wheels, etc. So although there are challenges, as I mentioned, in increasing the usage of aluminium to a large scale in automobiles, there are success stories in India itself. As you know, Vizag produces aluminium alloy wheels. Earlier, they were producing only for secondary market, but now they produce this LPDC cast alloy wheels for OEMs, nearly 10 or 12 OEMs they supply. Also in the Western countries, the corporate average fuel economy or the CAFE regulation, which aspires to reduce greenhouse emissions and increase mileage, has fueled large-scale introduction of aluminium on Ford's Ford 150 pickup truck. As we know, we belong to a different generation, but the younger generation is very sensitive about greenhouse emissions, and they are almost demanding from our generation that we need to come up with green technologies. In fact, the Honorable Minister himself said, why don't you propose a green steel or green aluminium for the eastern sector, so that there will be less resistance from the local communities in establishing those technologies. Apart from Ford 150 pickup truck, Tesla, the electric vehicle manufacturer, Honda Acura, there are also some of the other automobiles which use aluminium significantly. But why Ford 150 is significant is because they make a huge 650,000 units vehicles per year. The reason it has, of course, succeeded in this Ford 150, which is a substantial aluminium, if not all aluminium pickup truck, is that it's a very niche product. So the overall vehicle cost is also high. And so the material cost is not a significant fraction of the total cost. And it is precisely for similar reason that metals like aluminium have been extremely successful in the aerospace sector, because aerospace sector is less price sensitive. The vehicle costs are high. Not only that, the launching costs for rockets and missiles, satellite launch vehicles are a significant, they're significantly affected by the weight of the vehicle. So there are several cost estimates. So every kilogram that you save on the rocket launcher is a great benefit. They can increase the payload, or they can reduce the capacity of the propulsion systems. So rockets and missiles are big users of aluminium, apart from many other light materials. And what's more, the Boeing 787 and A350. So these vehicles, actually the aluminium usage has come down from the days of Boeing 747 when aluminium was about 80%. Now Boeing 787 aluminium percentage is only 20%. And why that has happened? Because of the factors that I mentioned earlier, the other competing metals like titanium and composite. And you may ask me why titanium can replace aluminium. Titanium is a heavier metal. But what happens is that when you replace some of the aluminium by composite, aluminium and composite form a very dangerous galvanic couple. So when you use a CFRP, aluminium parts start to corrode very fast. And so some of the parts of aluminium which were joined with titanium, which were joined with CFRPs, had to be replaced by titanium. So this 15% of titanium inroad into the aerospace vehicle is purely because of the galvanic incompatibility between CFRP and aluminium. But however, I'm not saying that there are no solutions. People are quite worried about the higher weight of titanium and also the higher cost of titanium. So if one can find solutions to the galvanic mismatch with proper sealing the joints, then aluminium can regain its lost place in the aeronautical sector. Now, building and construction, which of course is the largest consumer of another important metal, that is steel, not the number one consumer for aluminium, but building and construction also is an important industry which is expected to grow to the third position in 2030 in the world. Hence, applications like doors and windows, roofing, cladding, curtain walling, structural glazing, hardware, etc., will automatically come into the play once the infrastructure gets a push. Then aluminum for packaging is an important aspect. Recently, in the last 1.5 years, we have seen that the growing pharmaceutical sector, liquor, food and beverage sector, and the FMCG industry, the ban on plastics by several states, that has led to the increased usage of aluminum in packaging. And there is a change in the lifestyle towards online food delivery, which last 1.5 years has grown in an unprecedented manner. Recently, you might have read the offering by Zomato was like oversubscribed. So this online food delivery is also a very big sector now. And I think the aluminum foil applications, because of their flexibility, will find a large use in the market to make semi-rigid containers as well as for household foils, as well as even small applications like caps and cans for beverages will find big applications. So the aerospace sector in India, we read in the newspapers and all of you know, and I was intimately connected with the light combat aircraft program. And now a much bigger aircraft called the AMCA, the Advanced Medium Combat Aircraft, is at the design stage. It's a 5th generation fighter aircraft. And also there is an unmanned, various unmanned vehicles, I will only say that much, are also being planned in the country. And they are going to use significant amount of aluminum, but not the commercial aluminum alloys, but they will be the technology intensive high strength aluminum alloys of the 2000 and 7000 series, in addition to the 6000 series. So this is the trickiest product among all to get into, because it's crucially dependent upon the active involvement of the government sector. As of now, most of the aerospace industry in India is controlled by the government sector. But with more of LCA orders, you might have read about 6 to 9 months back that HAL received further orders from the Defense Ministry, from Indian Air Force, to produce more light combat aircrafts. And also with AMCA program taking a firm root now, the country will surely see high strength aluminum alloys coming onto the horizon. But the industry wants clear signals from the user agencies on their preference for indigenous sourcing of these alloys, because high strength aluminum alloys are not under any kind of embargo. They can be easily imported from global there are R&D agencies in India which have developed laboratory scale technologies. In fact, taking some trials also in companies like Hindalco, Balco has happened. Nalco was there for a long time in supplying high purity aluminum to the high tech aluminum alloys. Our institute has a role in training also. While we talk about numbers and investments, we have to keep in mind that the human resources are always equally given importance, and they are continuously skilled and reskilled. So our institute has been conducting courses for industry professionals. About a year back, we launched a program with CII and we conducted 3 courses. But as of this month, our CII contract is over, and now we are on our own. And this very month, actually, we offered first course in basics of data science in metallurgy and manufacturing, which got something like 150 participants, totally unanticipated. It put a huge administrative load on our group because the previous courses had got only like 40, 50 participants, but we got a huge 150 participants. The other course which just got over on Tuesday was lightweight materials for automotives. That also had about 50 participants. And in the month of September, there will be a course offered on aluminum alloy castings for the industry people by a combination of faculty from industry and academia. So what I'm saying is that in all our future manufacturing growth plans, we must make a space for training of the manpower, bringing them up to date on the technology. Today, we know that machine learning and artificial intelligence are coming in a big way, but then the basics of that lie today in statistics, artificial neural networks. So people have to be trained on these new techniques so that the manufacturing can become also more efficient. So it's important not just for IIM, but all other professional bodies to engage in training and reskilling of the manpower. We are trying to engage ourselves with the MSME ministry as well as the AICTE, whether they would like to support this initiative of skilling the manpower to be technology ready so that we take full benefit of the growth potential that the country is going to witness. China has done that just because they noticed that the rare earths are going to be the next best thing. They established 3 institutes completely devoted to rare earth metals. So just imagine if there is one academic department which works completely on aluminum alloys, all aspects right from bauxite to the high technology products. I think the country should also be taking a technology leapfrogging is very important for us. We cannot be chasing the outside countries all the time so that we become a net exporter of aluminum alloys rather than importers. With this, I will stop here. As I said, the picture seems to be, to me, positive from our IIM point of view. And I think if we focus such as I mentioned, like Eastern Indian states where most of the metals are being produced, I think our job will be a little more better defined. We can seek help from the government sector. And I think then those models can be replicated elsewhere in the country. Thank you very much once again, Gnaneshji, for inviting me here. As you told, I am just president for IIM for another 2 days or so. I'm laying down office, but I had a very satisfactory year. We launched many programs actually. Let me also mention, since some of you are from in that eastern part of the country, is that now we have a joint collaboration with Kalinga Institute of Industrial Technology, where we are going to establish a stream in metallurgy for the non-metallurgy graduates. We will be offering a minor course in metallurgy for those people, for aerospace, chemical engineers, mechanical engineers, industrial engineers, and eventually PG diploma. The syllabus is all made and the MOU has also been signed. So very soon you will find a joint IIM KIIT program in metallurgy being offered by that institute, which is already deemed to be a university. Thank you once again, and wish Aluminium all the best and wish Metal World all the best. Gnaneshji has been doing these programs very regularly. I follow most of his programs and he's doing a great job. Thank you.
Thank you, Professor Gokhale. It has been a wonderful speech on technology and everything futuristic. We really loved it, and that was a great speech, Professor Gokhale. And even if your tenure is over, I am very sure that you will be around and you will be with the industry and guiding the industry in the future as well. So thank you very much for
yes, sure.
With that, friends, we are coming to the end of this inauguration session, and we had wonderful speeches from Mr. T.K.Chand, Dr. Ashok Nandi, and Professor Gokhale, and that has really set the tone of this conference. And in fact, we have panel discussion coming up, and after that, after lunch, we have business sessions 1 and 2. So all that will be, I am very sure, will be very interesting and very learning experience for all of us. And I once again thank these dignitaries for joining us. And that brings to the end of this session. Thank you very much for joining this session. And we will be starting our next session, which is a panel discussion on the present status and the future prospects of aluminum industry in this country. And it will shortly start, and let's have a break of 5 minutes. Thank you very much, sir. Thank you. Thanks.
Thank you. Thank you.